Hi guys, we have a slightly longer lesson today, so if need be, I will cut it into two parts. Before I start here, I just want to let you guys know if you go to homework info, for lesson 5, I've added questions 5, 11, and 14, solutions, as well as a video explaining how to do that. And for lesson 6, I've just added some homework hints, but I think with these hints, you guys will be able to complete the questions without any issues. Let me know if you need further help. Again, a homework help, just post what questions you would like help with, and I'll try to have that answered for you as soon as I see it, okay? So anyways, let's go to get started on our lesson today. First thing I want to do with you guys is looking at perfect squares in a trinomial, and then we're going to look at more complex forms where we have a monomial within our first or second term. So the reason we call this one a perfect square is because the final form of this polynomial turns into one factor form to the power of 2. Okay, so how do we do that? Well, we look at the first term and the last term. It is a perfect square if b equals 2 times the root of a times the root of c. And I wrote a plus or minus here because technically I can have a negative number to the power of 2, or I can have a positive number to the power of 2. And it's going to matter, okay? It's going to help you determine which root to use, because we'll get a minus or plus b over here as well. Okay, so our final form then is going to be root of a x plus or minus root of c. Simple as that. So perfect square, you'll be able to do it really quickly just by looking at a problem. So let's go through this one step at a time. Which of the following are perfect squares? Well, just from eyeing it, the first one I have a root of 1 because it's 1 squared over here, and here I have a root of 2. Well, 2 times 1 times 2 gives me 4, positive 4. So yes, this is a perfect square. Second one here, I have a root of 1 in the front, and I have no roots here, okay? 6 has no roots, so I can't do that. See here, I have a root of 2. Well, actually, to be technical, I have a root of 2x because this is 2x to the power of 2. And in the back here, I have root of 9 to the power of 2. Okay, so how do I get negative 36? Well, I can do 2 times 2x times 9, and obviously that gives me positive 36x, and I need a negative 36x. So I'm going to do that by either putting a negative here, or I can put a negative here. You can try it out yourself, but it doesn't matter where you put the negative sign. Either way, you're going to factor out to, you're going to come out with the same perfect square factor. Okay, so yes, this one is a perfect square trinomial. And what about our last one? My first term here factors out to be a 1y, and my last one is 4 times 4 to the power of 2. But is it? It can't be. Whether I have a positive 4 to the power of 2 or a negative 4 to the power of 2, either way, I end up getting a positive 16. There is no perfect square that gets me a negative 16. So for D, it is not possible. Anytime you see a negative number for your constant over there, it cannot be a perfect square, so don't be fooled. Alright, so fill in the blank so that each of the following is a perfect square. A and B are fairly simple, so I'm going to leave that to you guys. I want to work with one that actually has a coefficient greater than 1 in my x2 here. Okay, so I'm going to look at my first term. Root of my first term is 5x, because 5x squared gives me 25x squared. Root of my last term is 6 here, so I need something that's 2 times 5x times 6. And what does that give me? Well, it gives me 60x. So my middle term must be 60x for it to be a perfect square trinomial. First term here is 3m squared. Alright, so I know that 24m equals 2 times 3m times something. So 24m divided by 6m then gives me 4. So my last number is 4 to the power of 2. In other words, I can write 16. And that will give me a perfect square trinomial. So now let's actually try factoring this, okay? So just by eyeing it right away, you can see here, okay, my first term is 7x and my last term is a 1. I see in the middle here, I have to have a minus 14x. So this must be a minus 1. Or maybe this is a minus. Okay, and if you're not convinced that I can put my negative sign either in front of 7x or minus 1, I have done a proof for you here, so you can have a look at it later, okay? Alright, of course you can try it yourself to convince yourself that it's actually right. So according to my original form, then my final answer is the root of the first term minus the root of my last term to the power of 2. Let's try the second one here. My first term is 4 to the power of 2, and my last term here is 5x to the power of 2. Note that it is the same thing as what we always write, except backwards. You can flip it around if it helps you see it a little bit better. That means my final answer, you can write it like this, 4 plus 5x to the power of 2, or of course you can flip it around. I like to make sure that my largest degree is always in the front instead of in the back, just to keep your work nice and neat. Okay. Oh, and I didn't do the middle verification part, but you can see here we have a positive sign. 4 times 5 is 20 times 2 gives me a 40. So see here, now we're working with the fraction, but I want you guys to not get thrown off by this because this is a fraction that we can split up. So 1 over 3 to the power of 2. Remember what this means is 1 over 3 times 1 over 3. And when we have two fractions that multiply each other on the bottom, we multiply top and bottom by itself, right? So 1 times 1 is 1, 3 times 3 is 9. So the square root of our first term is 1 over 3a to the power of 2, and this one here is 3b to the power of 2. The question is, does it give me my middle term here? So let's try that. Negative 2ab should equal to 2 times 1 over 3a times 3b. I'm going to rewrite it so that it's easy to see. 1 over 3 times 3 over 1 ab. 3 times 3 is 3. 3 times 1 is 3. 3 times 1 is 3. So together these cancel out and I have 1 for that value. So my answer here is yes, it equals 2ab. The only thing I am missing then is a negative sign. Similar to what we tried all the way over here, I can simply put my negative sign either in front of negative 7 or in front of minus 1. Okay, oops, sorry, I erased the 7. So I add a minus sign in front of, let's say, 3b. So that means my factored form is 1 over 3a minus 3b squared. And I'm done. This would be the same as 3b minus 1 over 3a squared. Both works, okay? So before I move on to the next part, I would like you guys to try questions 1 to 3 in your homework. So for this part, questions 1 to 3 will help you practice doing perfect squares. Next video is going to be about complex factoring, and you can click on that on the side here.